Okay, so here is the review. I think I've mentioned that the majority of the time on this test is going to be spent looking at section 3. But there will be at least one identity problem. It'll be fairly straightforward. So the ones that you're going to be responsible for are the reciprocal identities, the quotient identities, and the Pythagorean identities. So I'm going to go ahead and write them out. You can put them on your cheat sheet. So the sine of u is 1 over the cosecant of u. The cosecant of u is 1 over the sine of u. The cosine of u is equal to 1 over the secant of u. The secant is 1 over the cosine. Then we have the tangent is 1 over the cotangent, and the cotangent is 1 over the tangent. Okay, so those are called reciprocal identities. Then we have the quotient identities. So those are just two functions, which is the tangent, which is the sine over the cosine, and the cotangent, which is the cosine over the sine. So that's the second kind. So that's reciprocal, quotient. And then we have the Pythagorean identities. So we have 3. Sine squared of u plus cosine squared of u equals 1. And remember, this is sine squared is the sine of something squared. So if you have to evaluate sine squared of something, you take the sine of it and then you square that value. So just clarify that. Now, you can get the other two identities by dividing the kind of the one that's used the most. If you divide everything by the cosine squared, so everything's divisible by the same thing. So sine over cosine is tangent, so we get tangent squared of u plus 1, cosine over cosine squared over cosine squared is 1, and 1 over the cosine is the secant, so that's that one. And you can do the same thing. Now, you don't need to include that in your cheat sheet. It's just that I find this one is easy to remember. These are more difficult to remember if you were trying to do it. So what you do is, in the second case, is you divide everything by the sine squared of u. So you get 1 plus cotangent squared of u equals cosecant squared of u. So those 3, this, and this, are the Pythagorean identities. So what kind of problems might we have? Well, I'll actually tell you. Well, I'm going to give you verifying a trig identity. So you can go back and look at the homework of those. And yeah, you're going to have to use at least 2 out of 3 of these particular identities. So let me just see if I can find one here that I'm not sure what I assigned for homework, but if you ended up with something like 1 minus cosine squared of u, or 1 minus sine squared of u, so when you see the trig function, cosine or sine or tangent, so the other ones would be something like, if we go down here to this other identity, so you might have 1 plus tangent squared of u and what's the other one? 1 plus cotangent squared of u. If you see these kind of things, I guess, yeah, these kind of go together. If you took this identity and you had secant squared of u minus 1, then that would be equal to the tangent squared, or if you saw cosecant squared of u minus 1. All these cases where you have a 1 or a negative 1 matched with it, you can use the Pythagorean identities to replace those with just one term, usually trying to replace two terms with a single term. So these are all just the Pythagorean identities solved for this part, which is the part that you're typically trying to replace. Now, if you're given something like, if you have, let's say you have tangent squared of u, you're probably not going to replace that with secant squared minus 1, because that just makes it more complicated. So just because every time you see something squared doesn't mean to use the Pythagorean identity. It usually means if there's something squared plus or minus 1, or some variety of this. But if you're given something that's the tangent of squared of u, instead of replacing it with secant squared u minus 1, you probably want to convert everything to sines and cosines. So if you see tangent squared of u, I would replace it with sine squared over cosine squared. And if I see cotangent, I'd probably replace cosine squared over sine squared. So let's just say we have something like cotangent squared of u times 1 minus cosecant squared of u. Okay, so, and that's equal to something. We're trying to trig identities. What you do is you just try to simplify the more difficult side to equal the other side. And since I just made this up, I'm not sure what the answer is yet. So let's see what we do. So here we have 1 minus cosecant squared of u. Here I have cosecant squared of u minus 1. So what I could do is replace this with negative the cotangent squared of u. So if you don't have, if these are opposite, instead of this minus 1, if it's 1 minus that, then you can just, if I multiply everything by negative 1, I'd get 1 minus cosecant squared. So you can still, even though it's not exactly matching up with that, you could make that replacement. So in this case, you probably, since like I said, I just made this up, that probably would not be, you would just get negative cotangent to the fourth, and that probably would be it. So let's just replace this with, let's say this is, instead of cotangent, let's say it's, okay, so let's say it's sine squared of u. Well, when you replace 1 minus cosecant squared of u with negative cotangent squared of u, then, as I said, if you have these by themselves, then you could replace those with the replace the cotangent with the quotient identity. So you have cosine squared over sine squared. And you see here now these cancel out, and you get negative cosine squared of u. So if this was the original identity, and then I got down to this point, and when I evaluated the left-hand side, I'd get the same as the right-hand side. And if at this point, when this reduces down to the right-hand side, then you verified a trig identity. Okay, so like I said, 1 or 2 trig identities won't be super confusing, because I know that can be an issue. Okay, now we're going to do some problems from section 3, which is most of the problems. So there's really three kind of situations we're going to have. One is where I want you to find the solutions between 0 and 2 pi. Somewhere I'm going to ask you to find the solutions between 0 and 2 pi plus all solutions. And then finally, multiple angle situations. And also, some of them you can use unit circle to answer the questions. All of them you can use the technique of finding the reference angle and then finding the quadrants that the solution exists in. So I'm going to do all of those different arrangements. They may not be exactly the same as the test, but I don't want it to be too predictable. Okay, so let's say I have an equation that is 2 cosine of x equals negative the square root of 3. So, and I ask you, what are the solutions from 0 to 2 pi? Now, if you just have a single, if we have a single solution, which we do, not a single solution, but we don't have any plus or minuses because we're not taking the square root of anything initially. We do have a square root, but we don't have cosine squared, so we just have cosine. So all we do is solve for the cosine of x, and then we ask the question, what are the solutions to this problem between 0 and 2 pi, just between 0 and 2 pi, and there are going to be two solutions. There's going to be two quadrants where the solution is. So let me do it both ways. One is using the unit circle, and you can bring your unit circles for the test, and I'm going to just kind of sketch it. You can look at your unit circles to verify what's going on here. So here's my unit circle, and remember the cosine of x, or theta, I'm going to call it theta because on the unit circle thing we have x and y. So the cosine of theta is negative the square root of 3 over 2, and this is the x coordinate. So where is x equal to negative the square root of 3? Well, the options we have here, well, first is it's in the second, third quadrant because x is negative in the second, third quadrant. And we really have 3, 4, 5 positions. We have 0, we have a half, we have the square root of 2 over 2, we have the square root of 3 over 2, and we have 1. So half is here, so the square root of 3 over 2 is going to be moved over, so it's not centered, it's towards negative 1. This is closer to negative 1 than it is to 0. Okay, so then you can take your part of the problem is it's not round, but what you're going to have here is an x coordinate of the square root of, let me do this with an actual circle because otherwise it's going to be hard to see it, and you're going to have a unit circle to scale. So okay, so again this would be a half, and if you go over here, the square root of 3 over 2 is much closer to that. Okay, so there's two solutions here. So if you look on your unit circle, this is the one that's the most counterclockwise without actually hitting pi. So this is going to be 5 pi over 6. So make sure you verify this, and this is going to be 7 pi over 6. In between is 6 pi over 6, which is pi. So from that, you can find the angles. And I'm going to, notice it's in pi, so don't give me degrees or you're not going to get any credit. So the answer is here off the unit circle. The solutions are theta is equal to 5 pi over 6, and theta is equal to 7 pi over 6. Okay, so that's how you would do it using the unit circle. And I want you to draw this picture so I know you've thought about it. Okay. Now the second way of doing it is our 4-step process, 3-step process in this case, because I'm just asking for the solutions between 0 and 2 pi. So the first step is, which quadrant? Okay, all students take calculus, and we're dealing with the cosine, so we don't have to do all of them. Cosine. All are positive in the first quadrant. The cosine is positive in the fourth quadrant, so they have to be negative in the other two. So you can see that agrees with what I see in my unit circle. It's second quadrant, third quadrant. But here you don't have to draw the unit circle. Okay, so now the answer is Q2, Q3. Okay, step number 2, reference angle. So we'll call it x prime. X prime is going to be the inverse cosine. Remember, we use whatever the trig function is we're dealing with. The inverse cosine of the absolute value of the square root of 3 over 2. So we plug that into our calculator, and it's negatives. But then we're going to take the absolute value. So take the inverse cosine of the positive the square root of 3 over 2. So I've gone ahead and taken the absolute value. And make sure your calculator is in radians, which mine wasn't, so I got 30 degrees. But so I'll take the inverse cosine of the square root of 3 divided by 2. And what I get is the reference angle is 0.523598. Okay. So divide this by pi. So 5.5235 divided by pi is 0.167 pi. And I want you to convert that decimal into the fraction. So if you don't remember, 0.166 is 1/6, 0.25 is 1/4, and 0.33 is 1/3. Those are the only three that we're going to use when it comes to converting to fractions. So you get 1/6 pi, which is pi over 6. Okay, so that's my reference angle. Then step 3 is to get the solution based upon the quadrant. So I'm going to write these out. You want to write these on your cheat sheet. X, so the first quadrant, the solution is the reference angle. Second quadrant, solution is pi minus the reference angle. Third quadrant solution, x equals pi plus the reference angle. And the fourth quadrant solution is x equals 2 pi minus the reference angle. And you only need to write out the ones that are applicable. You just want to make sure these are on your cheat sheet. So we don't need to worry about that because we don't have a first quadrant solution. We don't have a fourth quadrant solution. So our solutions here are pi minus the reference angle. Pi is 6 pi over 6. We do that to get the same denominator. So you get 6 pi over 6 minus 1 pi over 6. 6 minus 1 is 5, so you get 5 pi over 6. And then the third quadrant solution, we get pi plus the reference angle. And that's, again, 6 pi over 6 plus 1 pi over 6. 6 plus 1 is 7. 7 pi over 6. So there's your solutions. Get the same answer. Okay. So I could give you a similar problem with sine, with cosine, with tangent. You don't have to do any factoring. You're going to get two solutions. Okay, now the next situation that you may run into, it may not be next on the test, but it's the next one I'm going to do, is where you have some kind of a squared situation. So let's say I have the cosine squared of x plus, what am I going to do here? Let's say we have 2 cosine of x plus 1 equals 0. So what you do is you don't have to factor this because we don't have a middle term. What we can do is we can take the constant to the other side. And actually, this has to be minus. So this is minus. So you add 1 to both sides. Divide both sides by 2. And then you take the square root to get cosine. But as a consequence, you have to add this plus or minus. Because minus 1/2, minus of this squared gives you positive, and negative of this squared gives you positive. So you can have 2 solutions here. Now in this case, that doesn't look like what we normally do, but we think of a half, square root of 2 over 2, and square root of 3 over 2. But if I simplify this thing by multiplying, dividing by the square root of 2, I'll get plus or minus the square root of 2 over 2. Oh, sorry. Square root of 2 over 2. So in this case, it's kind of like the original problem. Except that instead of just having a minus solution, I have plus and minus. So all we have to do is say, okay, instead of having using one of these numbers, we use both the plus and the minus, and then the rest of it's the same. Okay, so again, what we would do is if we did it using the unit circle approach, you'd pull out your sheet. I would just draw a little picture here. And in the case of, let's say, this situation, we'll use blue for that. Or that's not, we'll use red for that. So in that case, the square root of 2 over 2 is 0.707. So let's just draw a vertical line here. So this would be x, cosine of x equals 1/2. Cosine of theta is 1/2. This would be square root of 3 over 2. Square root of 2 over 2 is right here. And if you draw a line from the origin right here, you're going to be right in the middle. Because remember, this happens at 45 degrees or pi over 4. They have the same value. The cosine and the sine have the same thing, so it's kind of halfway between these 2 points. So in this case, you're going to get a first quadrant solution, and you're going to get a fourth quadrant solution. Now when you have the cosine negative, again using your unit circle, okay, so if I draw a blue vertical line here, again, there are 5 possible places on the unit circle. That one, that one. Okay, halfway, that would be a half. This would real close to that would be square root of 3 over 2. And if you go so that this thing is intersecting right halfway between the coordinate axes, so it's about right there. So it's, if I measure this, it's slightly to the left of 0.5. It's actually 0.707. that would give you the other two solutions. So you get that, and you get that. Okay. So from this unit circle, this solution would be pi over 4. This one would be 7 pi over 4. This one would be 3 pi over 4. This one would be 5 pi over 4. And you can read those directly off the unit circle. Again, I want you to draw these pictures, but you can get the numbers off of your unit circle. Again, if you don't feel comfortable doing that, and I'm going to do it anyway because we're going to use it in the next two for sure. So first thing, which quadrants? So cosine of x equals square root of 2 over 2, which is positive. That's going to be, all students take calculus, cosine plus in the first quadrant, fourth quadrant, negative in the second and third. So for this case, it's Q1 and Q4. And just like in the previous problem, when it was negative, cosine of x equals negative the square root of 2 over 2. It's quadrants 2 and 3. So anytime you have one of these plus or minus things, you're going to get a solution in every quadrant, no matter what it is. Sine, positive sign will be in the first two quadrants, and the negative sign will be in the second, third, and fourth quadrants. For the tangent, it's the first and third quadrant positive, second and fourth quadrant negative. Okay, so that's the first one. Calculate the reference angle. That's equal to the inverse cosine of the absolute value of the square root of 2 over 2. And actually, you could put in plus or minus. So all of these are going to have the same reference angle, because when you take the absolute value of positive, you get positive. If you take the absolute value of negative, you get positive. So, ultimately, both cases we're going to just have the square root of the inverse cosine of positive, the square root of 2 over 2. So plug that in your calculator. Inverse cosine of square root of 2 divided by 2. You get 0.7854 radians. If you don't put radians down, I'll be okay. Okay, so you divide by pi. So take 0.78 whatever and divide by pi, and you get 0.25 pi. And 0.25 is a quarter. And 1/4 pi is the same as pi over 4. Okay, so that's my reference angle. Now if I come back over here to these pictures, my first quadrant solution, which is this one, is just the reference angle. So I get pi over 4, which corresponds to that. Then I have my fourth quadrant solution, which is x is equal to 2 pi minus x prime. So I get 2 pi minus pi over 4. But 2 is 8/4, so that I have the same denominator. So I get 8 pi over 4 minus 1 pi over 4. And that equals 7 pi over 4, which is that solution. And then I have my second quadrant solution, which is x is equal to x prime, or pi minus x prime. So I get pi minus pi over 4. That's 4 pi over 4 minus 1 pi over 4. So I get 3 pi over 4. That's that solution. And my third quadrant solution is x is equal to pi plus x prime, or x prime plus pi, whichever way you want to go. And so we get pi plus pi over 4, which is 4 pi over 4 plus pi over 4, which is 5 pi over 4, which is this solution. So you can see again them all. Okay, so got something like that. I'll also give you something where you have to factor. Actually, I'll factor it for you, but let's say we have, let me think what I want to do here. Let's say I have 8 tangent squared x minus 2 tangent x minus 1 equals 0. So I've got this quadratic equation that is not, it has this middle term now. So what you have to do is you have to factor it. So the way I would factor it here is 8, not 8. Two numbers are multiplied together give me 8, which is 8 and 1, but I'm going to, in this case, to make this work out, I have to have 4 tangent x, and I have to have 2 tangent x. And these are going to be 1. One has to be positive, one has to be negative. So because I've got a negative 2 here, and the difference between these two numbers, 4 and 2, is 2, it's going to put a negative here and a positive there. So you can see 4 times 2 is 8, so you get 8 tangent squared. You get plus 2 tangent minus 4, that gives you minus 2, and then positive 1, negative 1. Okay. Now, from this, you can set both of them equal to 0, and then they each become just like the first problem. 2 tangent x minus 1 equals 0. So tangent of x is equal to negative 1/4, and the tangent of x is equal to positive 1/2. Now you might think, oh, I can do that in the unit circle, but that's sine and cosine. It doesn't work for the tangent. So in this case, they're not unit circle things, so you have to use the reference angle approach. So step 1, quadrant. All students take calculus, tangent. They're all positive in the first quadrant. Tangent's positive in the third quadrant, therefore it's negative in the second and fourth quadrant. So here I have a negative, so I know that this is going to give me a solution in the second and fourth quadrants, here and here, whereas over here it's going to be the other two quadrants, Q1 and Q3. Now, actually, let's go back to the last problem, because I didn't demonstrate how you get the solutions between all the solutions, so I forgot about that. Okay, so let's regroup here. So, you know, we had this, these are the 4 solutions between 0 and 2 pi. So for 0 and 2 pi, we've got x equals pi over 4. That's my first quadrant. 3 pi over 4, second quadrant. 5 pi over 4, third quadrant. 7 pi over 4. So if I ask also for all solutions, this is solutions between 0 and 2 pi, all you have to do is take the solutions between 0 and 2 pi and add 2 pi in. And then you've got to write this in is the set from negative infinity, and then I show integers near 0, and then go dot 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 dot, close F. So don't forget the n. Okay, so that's how you do it. And if if you're only If you're just dealing with you know, the cosine of x, just a single angle solution, that's all you have to do. Now, the only angle where this is true is this midpoint. So you could actually you could combine all of these into one expression, but you can't do this for anything except this particular case. So don't try to do this. I'm just, somebody may say, what, couldn't you do this? And it's true. You could say it's x equals pi over 4 plus pi over 2 times n. So when n equals 1, you get this solution. When n equals 2, you get that solution. When n equals 3, you get that solution. And then, so, you know, you could simplify this down, but I wouldn't want you to do that because, like I said, it's only when you have these quarter points that you can do that kind of a simplification. So, okay, so back to the problem here. So I want to find all solutions with this as well. And again, because these are just x, if I find these 4 solutions, I can just add 2 pi n to that, to the solutions between 0 and 2 pi to get the right answer. Okay, step 1 is that. Now, in this case, we're going to have to calculate 2 reference angles because these are not the same. You know, the -1 is different than the +1. In the previous problem, because they were all because we took the square root and we got plus or minus some number, then we only had 1 reference angle. But in this case, we're going to have 2 reference angles, one associated with this part and one associated with that part. So we'll put a line between here. Okay, so the reference angle for this is going to be equal to the inverse tangent of the absolute value of -1/4, which is the inverse tangent of 1/4. And I get 0.24497 radians. And if I divide that by pi, I'll get 0.07798 pi. So that's my reference angle for these 2 solutions. And here you take the inverse tangent of the absolute value of 1/2. So the inverse tangent of 1/2 is, okay, so let me just do this. So it's already positive, so it stays positive. When you do that, you get 0.4636 and divide by pi, we get 0.1476 pi. That's step 2. Okay, step 3. Find the solution. So for this one, it was quadrants 2 and 4, and for the over here it was quadrants 1 and 3. So my second quadrant solution is pi minus the reference angle. So I get pi minus 0.07798 pi. So that's pi times 1 minus 0.07798. So plug that into your calculator. 1 minus, so you should never put pi in here because pi is by itself separately. Okay, so 1 minus that is 0.922 pi. So that's x. That's my second quadrant. So I guess that should be x. Okay, so that's my second quadrant solution. My fourth quadrant solution, so this is Q4, is 2 pi minus x prime. So if I have 1 minus that, I get 0.992. If I get 2 minus that, I'll get 1.922 pi. And you could write it out. You'd have 2 pi minus point blah, 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 and then you'd factor out, you get pi times 2 minus that. But because the difference between here and here is 1, this is 1 more. Okay, so that's my fourth quadrant solution. Okay, so the first and third quadrant solutions, we use the second reference angle. So our quadrant 3, for quadrant 3, the solution is x equals pi plus the reference angle. But in this case, the reference angle is equal to 0.1476 pi. So it's pi plus 0.1476 pi, which is going to be equal to 1.1476 pi. And then the first quadrant solution, I should have done that one first, is going to be equal to just the reference angle. So for the first quadrant, x is equal to x prime, so it's going to be 0.1467 pi. Okay, so those are my solutions between 0 and 2 pi, so let's just write those out. I'll do them in order of quadrants. So our quadrant 1 solution is 0.1467 pi. My second quadrant solution is actually right here. I forgot to do that calculation. So let me just pause for a second. Okay, so the second quadrant solution is 0.922 pi. Third quadrant solution is 1.1476 pi. And the fourth quadrant solution is 1.922 pi. Okay, so in terms of all the solutions for all numbers, all you have to do is take these and add 2 pi into it. So that's the first quadrant solution. The second quadrant solution. Third quadrant solution. And the fourth quadrant solution. Now for the tangent function, you actually can just take the first and second quadrant solutions, but before we do that, we have to define n. Like that. Okay, but for the tangent, because of the way that repeats, all we have to do is take the first and second quadrant solutions. Instead of doing 2 pi n, it's just pi n. So that's my first quadrant solution, and then there's my second quadrant solution. So there's my first quadrant solution, my second quadrant solution. And what we do is have this end counter as well, because you can see over here how these repeat. These two repeat. So the first quadrant solution is the same as the third quadrant, the second is the same as the fourth, so we can do that. So let's do the sign. So let's say we have this 5 times the sine of 3x equals 2. So again, this is one where we can't use the unit circle because we're not going to have a nice square root of 2 over 2 or half or square root of 3 over 2. So, but you won't have to do any factoring or anything like that. It'll just be a simple situation like this. So if we divide both sides by 5, we'll get that. Sine of 3x equals 2/5. So the only difference is that we come up with another variable, which sometimes I use alpha, sometimes I use theta. So let's use theta today. So we say theta equals 3x, and then we do the whole calculation in terms of theta, just like we've done in any of the previous problems. And once we get the solution in terms of theta, then we'll divide, then we'll go back and we'll say, x is equal to theta over 3. And we'll make that substitution. Okay. Now another thing, what happens when you have this constant here, which is greater than 1, you'll end up having, it'll end up being a much more quickly changing function. This is going to oscillate 3 times when the sine of x oscillates 1 time. It's going to look something like that. So we're going to get the solutions for this between 0 and 2 pi for theta. And that will correspond to x between 2 pi over 3. So you divide everything by 3. 0 divided by 3 is 0. Theta divided by x divided by theta is x divided by 3. And 2 pi over 3. So the period of oscillation for this case, 3x, is 3 pi over 2. The period of oscillation for theta is 2 pi. Okay. So again, we'll come back to this later. Because, what if I asked what are the solutions for x between 0 and 2 pi? How do we do that? Because this is between 0 and 2 pi, but the x solutions are going to be between 2 pi over 3, between 0 and 2 pi over 3. So we want to do that, and we want all solutions. We'll actually do this one first, and then we'll use that to get that answer. Okay, so because we don't have any plus or minuses or any factoring, we're going to have one situation. So the first part is which quadrant? All students take calculus. So the sign, positive in the first quadrant, positive in the second quadrant, negative in the third and fourth quadrants. So we're going to have a first quadrant solution, we're going to have a second quadrant solution for theta. So then we calculate the reference angle. Theta prime is equal to the inverse sine of the absolute value of 2/5, which is the same as the inverse sine of 2/5. Okay, so get our calculator. Inverse sine of 2/5. So that's 0.4115. Put that in terms of pi, so divide that by pi. We get 0.1310 pi. Okay, so that's my reference angle. Then we're going to find the first quadrant solution. So theta is equal to theta prime, which is 0.1310 pi. And our second quadrant solution, so theta is equal to pi minus theta prime. So you get pi minus 0.1310 pi. So 1 minus 0.1310 is 0.869 pi. So that's my second quadrant solution for theta. Okay. So all solutions for theta. So we're changing things. You know, before we'd find the solutions between 0 and 2 pi, and then when you find all the solutions. What we're going to do now is we're going to find all the solutions in terms of theta. So what you have is you have theta is equal to 0.130 pi plus 2 pi n. And theta is equal to 0.869 pi plus 2 pi n. So those are my solutions for theta. Then all solutions for x. All you do is you divide everything by 3. So x is theta over 3. So x equals theta over 3. So we take 0.1310 over 3 times pi. Now we don't need to divide both. We only need to divide this one by 3, because if you divided it both by 3, you'd be dividing by 9, so that wouldn't be very good. And you get 2 pi n over 3. And let's go ahead and divide that by 3. 0.131 divided by 3 is 0.0436 pi plus 2 pi n over 3. So that's my first one, and then you do the second one, which is 0.869 pi divided by 3 plus 2 pi n divided by 3. So 0.869 divided by 3 is 0.2896 pi plus 2 pi n over 3. So those are my two. When I say all of them, that's all the solutions for x. Now, between 0 and 2 pi, we're going to have 6 solutions. So the way you would do it is you look at this number, 3. So evaluate equations for n equals 0, 1, and 2. So we go from 0, this is 3 minus 1. So whatever this number is, 3, you take 3 minus 1. If it was 2, you'd take 2 minus 1. So there you'd go, you'd do have 0 and 1. If you have 4, you'd go with 0, 1, 2, and 3. So here's n equals 0. You get 0.0436 pi plus 0. Let's just plug in the 2 pi over 3. So you get 2 pi times 0 over 3. So that's 0.0436 pi. Then you do n equals 1. So you'd have x equals 0.0436 pi plus 2 pi times 1 over 3. So that's going to be 0.0436 plus 2/3. And so you get 0.710 pi. And then you do n equals 2. So you get x is equal to 0.0436 pi plus 2 pi times 2 over 3. So that's 0.0436 plus 4/3 instead of 2/3. So I get 1.370 0.69 pi. So those are the three solutions associated with this equation. So let's just underline those here. So that's those three go along with this thing. And then you can do the same thing for the second equation. So you get x is equal to 0.2896 pi plus 2 pi times 0 over 3. So that would leave you with 0.2896 pi. Then you have n equals 1, which is going to be x is equal to 0.2896 pi plus 2 pi times 1 over 3. So I take 2/3 and add it to that. 0.2896 plus 2/3 is 0.9563 pi. And then we have n equals 2. So x is equal to 0.2896 pi plus 2 pi times 2 over 3. So you get 4 pi over 3. 0.2896 plus 4 divided by 3. That'll give you 1.623 pi. So those, the three equations, or the three values associated with n equals 0, 1, 2, and 3 are that. And so that gives you the 6 solutions between 0 and 2 pi. So when you do have these multiple angle situations, instead of having 2 solutions to this, you end up with 6 solutions. Now the good thing is, all solutions, there's just 2 equations for x here. Yeah, so these are 2 equations. No matter whether you have a single angle or a multiple angle, you're still going to have 2 equations to define all your solutions. But if you have multiple angle solutions, you're going to have 2 times n. Well, 2 times the number in front of the in terms of the number that's in front of x in the argument. Okay. Finally, I want you to be able to use the product to sum and difference formulas. And I'm just going to have you be responsible for the sine and the cosine. And I'm not going to work through the entire problem. You can go back and look at some of the problems because they're pretty straightforward. But you've got these, you got these 4 equations. So I'll go ahead and write them out. Make sure you get the letters right when you're copying this. So the sine of u plus v is the sine of u cosine of v plus cosine of u sine of v. You've got the sine of u minus v is equal to the sine of u cosine of v minus the cosine of u sine of v. And then you got 2 for the cosine. Cosine of u plus v is equal to the cosine of u cosine of v minus the sine of u, the sine of v. And the cosine of u minus v is the cosine of u cosine of v minus the sine of plus the sine of u sine of v. So those are the 4 equations. And what I'm going to ask you to do is to take, evaluate x equals something. So let's say I take pi over 4 and I add it to 2 pi over 3. So these 2 are on the unit circle. That's the whole idea, is you can get these values off the unit circle. So, but if I add these 2 together, I'd have 3 pi over 12. So this is, I'm converting this to twelfths because you got fourths and thirds. And that's usually what happens. They're usually twelfths. I guess they could, well, not, yeah, in this case, they're usually twelfths. So I convert pi over 4 to 3 pi over 12, and I convert this to, if you multiply the numerator and the denominator by 5, you get 8 pi over 12. 2 times 4 is 8. 2 times 4 is 3 times 4 is 12. So then you add the two together, 11 pi over 12. So what I'm going to do is I'm going to give you something like this, and then you have to figure out two angles that are on the unit circle that added to, or subtracted, added together, or one subtracted from the other result in this. So you have to go backwards to get these. Then you can look up these on your unit circle, or you can use in your calculator. I think I want you to use the unit circle here because you know, part of this whole process is just simplifying it. So, you know, you should be using, you know, this will be pi over 4, or any variety of it will be some version of the square root of 2 over 2. And then the other ones that are sixths or thirds, they're going to be either square root of 2, 3 over 2 or 1/2. So, you know, when you plug it into these equations, you're going to end up with probably square root of 2 over 2 multiplied by this, and then multiplied by that, and there's going to be pluses or minuses, and you're going to have to, you know, simplify them by finding a common denominator. So again, you can look at the examples. So there's one problem that does that, and then the second one is to use one of the multiple angle formulas. The one that we used the most was this double angle. So let me give you an example. Let's say if the cosine of theta is, yeah, I just realized let's say the cosine of theta is negative 5/8, and theta is in the second quadrant. What is the cosine and sine of 2 theta? Question mark. So what we can do is we can use the double angle formulas, and I'm not going to ask you for the tangent, so you can thank me for that. So we have these double angle formulas. Sine of 2u is equal to 2 sine u cosine u. So that's the one that involves the sine. The cosine, there's 3 varieties, and they'll all give you the same answer, so you can just pick whichever one you want. I'm not going to say anyone's easier than the other. I think they'll all take time to simplify. So those are the 3 double angle formulas. So the whole idea here is I give you the cosine of theta and the quadrant. So you should be able to figure out what is the sine of theta. And once you have the sine and cosine of theta, you can just plug them in here, and then you can simplify it. So let's do this. First thing is find sine of theta in Q2. So if I gave you the sine, you'd have to find the cosine. So think about this. So there's two things you can do. Two ways you can think about it. One is you can find the coordinates that are associated with this. Remember the cosine of, I think we used r or something like that. Not r, cosine of t. They used t in the book. Cosine of t was equal to x over r, where r is the distance from the origin to the point in space. So if you think about this, I've got the denominator is always positive. That's r. R is always positive. So this negative has to go with the x coordinate. So you'd have negative 5 here. And then the distance from the origin to here would be 8. And this distance would be 5. So the distance for this other side, which I need to calculate the sine. Remember the sine of t is equal to y over r. So I know it's positive because this is y is positive, x positive that way. So here I have negative x, positive y, because that's the second quadrant. So the y coordinate is going to be equal to the square root of 8 squared minus 5 squared. That's just using the Pythagorean theorem for that triangle. Now you're like, well, should I use negative 5? Well, not really, because the Pythagorean theorem has to do with, I mean, theoretically it would work because you'd square it, and so it doesn't matter, but I don't think it's appropriate to use a negative sign in there. So you just have to think of this being a right triangle. Okay, so you get 64, 8 squared minus 25, 5 squared. You get 39, so this is the square root of 39. So this side is the square root of 39. So using this coordinate approach, you'd say the sine, let's use theta here, sine of theta is equal to y, which is the square root of 39, divided by r, which is 8. So I have the sine of theta equals that, and the cosine was negative 5/8. Now the other approach would be basically to make this into a right triangle, just like we did, and then say, okay, I'm in the second quadrant. The sine is positive in the second quadrant, so opposite over hypotenuse is the sine for this triangle, assuming all positive lengths, but then taking that value, square root of 39 over 8, as the opposite over the hypotenuse, and then thinking, oh, second quadrant, the sine is positive, so I'll make it positive. That'd be the other way to think about it. Okay, so that's the first thing you can do. If I give you the cosine, you got to figure out the sine. If I give you the sine, you got to figure out the cosine, and I'll give you the quadrant it's in. So you can, given this sine, well, this sine will have to agree with the quadrant, which it does. So I can't. Okay. Now, once you've got those two numbers, all we have to do is say that the sine of 2 theta is 2 times the sine of theta, which is the square root of 39 over 8, times the cosine of theta, which is negative 5/8. So 2 times 5 is 10, so I get negative 10 square root of 39 divided by 64. And you could simplify this because you can divide both the numerator and the denominator by 2, so I get that. And then I could evaluate the cosine of 2 theta using any one of these expressions, so it doesn't really matter. So I'm going to pick the second one because that's the easiest one. I'll do 2 of them just to show you you do get the same result. Okay, so you get 2 cosine squared minus 1. 2 cosine squared. Okay, so you get 2, 5, negative 5 squared is 25. 8 squared is 64, minus 1. So 2 times 5 is 20, 2 times 25 is 50. So I get 50 over 64 minus 64 over 64. So that's negative 14 over 64, or negative 7 over 32. Okay, so that's the cosine of 2 theta. Here's the sine of 2 theta. Okay, let's do the same thing with the different. Let's do sine squared plus cosine squared. Okay, so the cosine was negative 5/8, so we get negative 5/8 squared minus the sine, which is the square root of 39 over 8 squared. So you square this, you'll get 25 over 64. Here we get 39 over 64. So this squared becomes positive. This is already positive. 25 minus 39 is negative 14 over 64. Divide both by 2, you get negative 7 over 32. Same answer. And let's just do one more. We'll do the last one. 1 minus 2 sine. Sine is the square root of 39 over 8 squared. So that's using this one. 1 minus 2 sine. So you get 1 minus 2 times 39 over 64. That's 1 minus 2 times 39 is 78 over 64. 1 is 64 over 64. 64 minus 78 is negative 14 over 64, which is negative 7 over 32. So there you go. Okay, so that's all I'm going to have on the test. Just make sure you know how to use the double angle formulas given the original angle, or the original sine or cosine and the quadrant.